So we'll try to see this set operations. So say I have a set A. Okay, so I'm saying A is equal to, I'm taking a set which is 1, 2, 3. Okay. And then I have taken another set which is B. Okay. And inside this, I'm giving 4, 5, and 3 and 2. Okay. So these are the two sets that I have taken. So now I want to find out the union of these two sets. Okay. So what I can do, I can simply say A, and then I can give this type operation and I can give a B like this. Okay. So this I can do. Or else what I can do, I can also say A dot union B. Okay. So that also I can do. Okay. I can also say print. I can also say A dot union. Okay. And I can give a B over here. Okay. So let us run and see the output. Okay. Can you see the output, ma? All of you?
Yes, ma'am.
Yes,
ma'am.
ma'am.
This is the union. So you can see that the duplicates are eliminated, right? So the union of the two sets, like it is 1, 2, 3, 4, 5. You can also give a pipe symbol, or else you can also give this kind of method, like union method, like A dot, this kind of syntax, like A dot union B. Okay, so this is regarding union. Okay, so now let us see what is meant for intersection. And so what is the symbol to find the intersection?
Ampersand.
So it's an and, right? So I'm giving an and over here. And also I can change this. I can say intersection. Okay. I said intersection, A dot intersection B. Okay. So can you see the output? What is the output? So what are the common elements?
2, 3.
2 and 3.
Okay, so 2, 3 or 2 and 3. Okay, so all these are correct only. Okay, so this is intersection. Let me show you by printing the set A. Okay, I'm printing the set A. So I'm just printing the set A. Okay, so what is there in set A? Is there any
1,
modification?
2, 3.
Yeah. Is there any modification that was done
No,
to
ma'am.
set A? No, right?
No,
Set
ma'am.
A is as it is. Set A is as it is. Okay. Now intersection update means that if you want to update set A with the result, okay, so you can do that. So what I'm doing, I am just changing here to intersection update. I'm just saying underscore. What is the syntax? I can say A dot intersection underscore, and I'm saying update. And now let us see. Okay, so I am just removing this print statement. Okay, so let us see. Okay, so this is a method which will not return anything. That's why we have got a none. Okay, so I can simply write it outside print because this has got no meaning if we just put it in the print statement because there is no return type for this particular method. Okay, so I just said A dot intersection update B. Okay, then I'm printing the value of A. So you can see that in the output very clearly. Okay, what it is showing me? What it is giving me? So what is the set A? What is there in set A?
2, 3.
2 and 3.
2, 3.
Okay, 2, 3 is what?
Intersection
Intersection update.
It is the result, right? It is the result of the intersection between A and B, right? Yes. So that result is now into set A. Okay, so all the elements of set A will go off and A will hold now the result of the intersection between A and B. Is this clear to everyone?
Clear, ma'am.
Clear, ma'am.
Clear, right?
Ma'am, difference
update one show, ma'am.
Okay, fine. I'll do that. Okay, so what we are having the set like this, right? So I'll do the difference here. Okay, so I just said, okay, so A dot difference B. Okay, so I can put it because this will give me the result. Okay, so this method will give me the result. So I can put it in the print statement. Okay. Okay, so what will be the answer?
1.
A minus B? It will be 1, right?
1.
Yes, you can see the output. Can you see the output?
Yes, ma'am.
Okay, so the first print statement is giving me the output, which is A minus B. Okay, but there is no change in the A set. You can see that because this is difference. It's not an update. This is just a difference. Okay. In the similar way, you can also find difference between B and A also. Okay, so you can simply say you can change the sets over here. So this will make B minus A. Okay. Let us try to see what is happening to the B set. Okay. So the B minus A is resulting in 4, 5. But you can see that there is no modifications in the B set. Okay. And that is one observation. And the other observation is that you can see that the order of the elements in the B set are not in the same order like how you have given. The order has changed. This is what is called as unordered set. Okay. Right. So I think the
Okay,
difference
ma'am.
is clear. Is the difference clear? Right.
Yes, ma'am.
Yes. Now we'll try to do the difference update. So I just need to give an underscore and then an update. Okay, I'm doing it on this B minus A, and you can see that there will be a change in the B set. Okay, so as I said that this difference update will not return anything. There is no meaning in putting in the print statement. Okay, you can see this none also on this. Okay. What happened now? Set B is updated. Okay, so with the result of B minus A. So what are all the elements that are there in B minus A? All that elements will be now in B. Okay, so the B original set will be lost and the resultant will be there in the B set. This is the difference between difference and difference update. Is it clear, ma?
Yes, ma'am.
We also will see the symmetric difference so that we'll be completing all the operations. Okay, so I am saying the okay. Yes, you can see that. Okay, so what is the symmetric difference? A cap B or B cap A? Only elements that are present in one group, right? So the elements that are present in only A and B, okay, so which are not even common. Okay, so those elements are 1. 1 is present in only A, and 4 and 5 are present in only B. Okay, so since we are finding the symmetric difference between these two sets, the result will be having 1, 4, and 5. Okay, so which is nothing but A cap B. So you can see that there is no update over here. So you don't have a method which is symmetric difference update and all that. So this is just a symmetric difference. Okay, so which will be giving a result to you, not updating any of the sets. The original sets will be as it is. They will be retained with its original values. This particular symmetric difference will give the result. That's it. Are the operations clear to everyone in my class?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. The next method that we are going to see today is the copy method. Okay, so copy method is used to make a copy of the existing set. So say I have a set which is S is equal to 1, 2, 3, and I want to make a copy of this set. You might be thinking that this set is very small. What is the purpose of making a copy? I can simply say B is equal to 1, 2, 3. But in reality, in real time, the sets will be very lengthy. Okay, so a set, say for example, the set of students. So your class itself, there are almost 64 students. So 64 students data and 64 students name and registration number, their age, their address, all this can be set, right? Okay, so all this can be a set. Each and every information that we are storing about the student can be a set. So the sets can be very long. Okay, so they can be very big. So this copy method will be very handy to actually make a copy of one set. Okay, so here S is a set which is having 1, 2, 3, and I'm saying B is equal to S dot copy. So here the syntax how to use the copy is that to make a copy, so I'll be using S is the original set and I want to make a copy of it. So I'm saying S dot copy. Okay, so this is the syntax. And since this copy method will return me the created set. Okay, so it returns. So you can see the description of the copy method here. So what did I write here? I said returns a copy of set S. So this returns something. The return type of this copy method is a set itself. So I need something to catch this particular result. So that's why I'm saying B is equal to S dot copy. Okay, so I said B is equal to S dot copy. Now what is there in B? In B, the copy of S will be there in B. So now B is a set which is having a copy of set S. Okay, so I tried to show you by printing the set B. So I said print set B is equal to, and I tried to print B. So you can see B is holding all the elements that are there in set S. Now the question is what kind of copy this is. Okay. So to show you that difference, I could actually stop it here and say that the copy is over. But I'm taking you deep into the subject. Okay, so to actually show you what kind of copy this is. So you can see that I am trying to print the IDs of S and B. So there are two IDs, meaning that there are two objects created. Okay, right. And so to show you that it is a deep copy, so B dot add, I'm adding an element into the set B. Okay. So what happened after adding the element into set B? So when I try to print the elements of set B, you can see that 4 is added into set B, not set A. Set A is as it is. Now what does this mean? Any modifications that you are doing to the copied set, okay, using the copy method, it will not reflect in the original set. Okay, so this is a very, very important interview question. Okay, so I hope everybody understood this. Okay, so you're having two copies. So it means that it, like you took a Xerox of it. Okay, so say I am trying to give you, I'm having an original copy of marks. Now what I did is I made a Xerox of the original copy. Now making modification in the Xerox copy will not make modifications in the original copy, right? I'm writing something in the Xerox. So that will not reflect in the original copy. Okay, so copy is something like that, making a Xerox of a paper. Okay, right. So any modifications you are doing in the copied set, it will not reflect in the original set. So I hope everybody understood what is copy.
Yes, ma'am.
Yes, ma'am.
Okay, so the next method is disjoint. What is disjoint? Is disjoint means that there is no common things in between the two sets. That is what is the description of is disjoint. It is saying that it returns true if two sets have a null intersection. What does it mean by null intersection? Null intersection means that there are no common elements between the sets, two sets that we are giving. So here the sets we are giving is S is the first set and B is the second set. S is holding 1, 2, 3 and B is holding 9, 7, 8. Okay, so now I'm trying to find this is disjoint set will return a Boolean literal. So it will return true if the sets have no common elements, else false. Okay, right. So because these two sets are disjoint, I'm getting a true over here. Okay, so no elements, no common elements between S and B. So that's why I got it true over here. Okay, so now what I'm doing is I have made a copy of this particular set S and I have put the same set in B. Now what is happening? What is there in set B? Set B is also having the same elements like set 1. Okay. Now both the sets are same. So common elements unnai. Now there are common elements between these two sets. That's why it's returning a false. So I'm showing you both the cases. Okay, so of true and false. If it is just disjoint, it is giving me a true. If there is at least one common element, it will give me a false. Okay, saying that they are not disjoint. Is disjoint clear?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay, now coming to the next method. So the next method is all S, where S is the set over here. So you're passing set S as an argument into this particular all function. So what does this all function do? It returns true if all elements in the set are true. Now all elements. Okay, so I already told you what does it mean by true and false in terms of Python. Now true means any other value other than 0. False means it is 0. Okay. So we are now looking into the numbers. So this is a set with numbers. So you can apply this on the numbers. Okay. So I'm saying set S is equal to 1, 2, 3. And I also have taken another set to show you that how it is written in true and false to show both the cases. Now in the first set, there are no zeros. Okay. So meaning that everything is true over here. So that's why it is written a true. Okay, so meaning that all the elements in the set are true because there is no zero in set S. Now coming to set B, there is one element which is non-true, which means one element which is false. The other elements are true. Say that I'm having 99 elements, 100 elements in a set, and 99 elements are true, but only one element is there, which is 0, which is false. Then the entire result of this particular all B will return me a false. Okay, so that's why, because there is one element which is false, the entire result of this operation is giving me a false. Okay, so this is regarding all S. To check, all S is used to check whether there are zeros in the set or not. Okay, now coming to any S. Okay, so it returns true if any elements in the set are true. Okay, so if one element is true other than 0, then it will return a true. If there are all zeros, it will return a false. Any. Okay, so here we are talking about any, meaning that any one being true. Okay, so if any one being true, then the result will be a true. Okay, right. Having 3 zeros and a 1 in a set. Okay, since there is one true, the result will be true. Okay, so at least one non-zero in the set, it will return a true for me. Okay, there is 0 over here. So what it is doing, it is returning me a false over here, and it also results in a false over here. So is this clear? Next is an enumerate function. Enumerate function returns an enumerate object. We know this, right? It will give the index and the value pair. Okay, that sets are unordered, right? So some random order of the elements, and then give indexes to those particular random order of the values. Okay, but it will give me a set, okay, of pair of index and values. So here you can see this is the set that I have taken with some values in it. And now I'm turning a loop for I in enumerate S. So this enumerate S will give me this particular pair, right? So it will just be having some random order of the elements, say 0, -1 also can be possible. Okay, so and then it is saying 1, comma, then 5 and all that. So it can give me in any of the order like this. So I'm just taking a help of print statement over here to print the elements on the screen for us. Okay, right. Navigate each and every index and value pair. So the first one will be 0 and 0. Okay, so in the next case it will iterate through the next element, which is 1, comma 5. It can be okay. So it needn't be the same output that you get. It can be different also. So I got 1, comma loop to iterate through the enumerate object and print the elements on the monitor. So is enumerate clear?
Clear, ma'am.
Yes. Okay, so now we'll look into the functions which are maximum, minimum, and sum. So which are represented as max, min, and sum. Okay, so the method names are max, min, and sum. These three methods will be taking a set as an argument. Okay, so max will take set as an argument, min will take set as an argument, and sum will take set as an argument. So here I have given all these methods in a single program. So I have taken the set like this, and I want to find out the min of S. Okay, so what's the minimum element? Minimum element in this set is -4. Okay, so the least element. And then I said max of S, which is giving me the maximum element. So the maximum element is S. And sum will actually sum all the elements in the set. So the sum of all the elements in the set is 10. Okay, so this is regarding max, min, and sum applied on a set. The next method is sorted method. Okay, so it is a sorted method. Don't forget, like, don't use sort. Okay, so it is sorted. Ed is there. And this sorted method will take a set S as an argument, set as an argument, and it returns the new sorted list from the elements in the set. It doesn't sort the set as sets are immutable. Okay, now here the point set over here, and then I just wanted to sort the elements in the set, and it is just sorting the elements and giving. I have printed the set also. Okay, you can see that very clearly. Now this sorted just have given me the result of it, but the original set is as it is. To show you that, I have to give me the elements in the set in sorted order. That's it. But which will not make any modifications to the set S. So this is a very important concept that we are going to look. Okay, so set cannot contain mutable objects, but set itself, the set, all of them should be immutable. Okay, so for example, I have element 1, 2, all the numbers are immutable. So what are the immutable things? Numbers are immutable, strings are immutable, okay, tuples are immutable. So we have seen all this, right? So all these three things that I'm mentioning are immutable. Okay, numbers are immutable, strings are immutable, tuples are immutable. Say you take int, float, all these are immutable. Okay, so that's why we can give them in a set. But here what I did, the third element I have given a set. I have given a list. Okay, just make an observation into this particular set. Okay, set A is having 1, 2, and then I have a list which is 3, 4, 5. Okay, so how many elements are there in this particular set? There are 3 elements in this particular set. Okay, so 1 and 2 are valid because they come under numbers. So numbers are immutable. So set can contain immutable objects. Okay, fine. But now coming to the third element, the third element is a list over here. Okay, 3, 4, 5, which is a list over here. Okay, so when I try to give a set, create a set in this particular manner, this is the output that I'm getting. What it is saying in the output, it is saying that type error, unhashable type list. Okay, so you cannot have a list. Mutable objects cannot be there inside a set. This is a rule, like, okay, fine. But you can create set from a list. Okay, so you can take a list, you can typecast a list and create a set. Okay, but the elements inside the set cannot be list type. Okay, so everything, all the elements inside the set should be immutable objects. It cannot contain, the elements inside the set cannot be mutable. Okay, but you can make modifications to the set. Okay, right. Now coming to this particular next example, so I just wanted to show you that tuples are accepted in a set. And a tuple is that list is mutable. You can change. But tuples are like the static list. Like there, if the list is created, you cannot change it. So tuples are accepted in a list, in a set. Okay. So tuples are accepted in a set, but lists are not acceptable because they are mutable objects. So here it is not giving me any error. It is just considering it as one of the elements in the set. Is this clear, ma? Everybody?
Yes, ma'am.
Yes. So this is the last slide of your sets. Okay, so let us just try to understand and summarize the content. Now sets are unordered, so we know that, and because they are unordered, so there is no meaning for indexing in the sets. Okay, so there is no indexing in the set. Like you cannot identify an element through the index number, like how you're doing in the list. Okay, so in the list, like you are unique. Okay, so they're unique. There are no duplicate elements are not allowed inside a set. And set itself may be modified, but the elements contained in the set must be of immutable type. This is a very, very important topic. You can modify a set, like you can add something into a set, you can delete something from a set. So set itself, but tuples are not like that. Tuples are immutable. You cannot add or delete anything from the tuples. But here set itself is mutable, only, but the elements inside the set are immutable. This is a very, very, in the previous case I said like there are 1, 2, and then I have a list like 5 and 8 and all this. So these are the elements inside the set, right? The quality of the elements inside the set should be immutable. Set. But coming to the overall set, okay, so coming to the overall set S, you can actually add elements into the set and you can also delete elements from the set. That is possible. That we are doing. We are changing the set. But having mutable elements as mutable objects as elements inside the set is not permissible. Okay, so that's what is the third point, which is very important. Okay, so what are the points that we have summarized? What are the points that we have summarized regarding sets? Sets are unordered, so there is no indexing for the set. So the elements in the set are unique. There are no duplicate elements inside a set. Even if you give duplicates elements, it doesn't throw me an error. But when it gives or when it considers the set, it will itself internally take off the duplicates and consider the set. Okay, and the elements inside the set need to be immutable. Okay, so what are the immutable data types? The immutable data types are numbers, strings, tuples. All these are immutable data types. So the sets can have objects of immutable data types. That's a rule. It cannot have mutable data types as its objects or as its elements. But on a whole, a set is mutable. Like you can change the set, like add and delete something from the set. Okay, fine. So this is the end of your sets concept. So what are all we have seen?